So already we seen alcohols, IUPAC nomenclature, classification of alcohols, now we are going to see alcohols preparation, properties and uses. And last topic in alcohols is phenols. So first two already we see. Now going to see preparation of alcohols. Preparation of alcohols. So already in 11th standard we studied nucleophilic substitution of halides and conversion of alkenes to alcohols. These are some of the preparations of alcohols. Before going to study this topic, we have to recollect one topic. Already we studied in 11th standard. Primary, secondary and tertiary halides or alcohols. Halides or alcohols. But you have only alcohols. So this one you will see. If it is primary alcohol means CH3, CH2, OH. That means functional group attached carbon attached with one carbon. So it is primary. In case if it is secondary, in case of secondary, this functional group attached carbon attached with two carbons, so it is called as secondary alcohol. If it is tertiary, means functional group attached carbon attached by 3 carbon. This one functional group attached carbon attached by 3 carbon. 1, 2, 3. So it is tertiary alcohol. So if it is primary means functional group attached by 1. This secondary means attached by 2. Tertiary means functional group attached by 3. So you by heart this. If it is functional primary alcohol means straight away you write it as it is ethanol. If it is secondary means propanol or propyl alcohol. Any one name you write, either common name or IUPAC name. So common name is ethyl alcohol, IUPAC name is ethanol. In case IUPAC propanol, common name is propyl alcohol. If tertiary means straight for a common name, tertiary butyl alcohol, IUPAC name. So already we studied 1,2-methyl propane 1-ol 2-ol. So IUPAC name is 2-methyl propane 2-ol. So very important topic. Once you know these 3 compounds, this alcohol topic is very easy because we are going to see this primary, secondary, tertiary repeatedly in the upcoming topics. Now we will see the preparation of alcohols. So first one, alkyl halide react with the NaOH. So already we know the eliminated product is CO2, H2O, HX, MX. In case of your X is there, metal is there, so NaX is eliminated, the product formed is ROH plus NaX. In this case, if it is primary halide, means undergo SN2 substitution. If it is secondary and tertiary halide, means undergo SN1 substitution. So these first two preparations. So next we will see second one is addition reaction. In this case, propylene undergo addition reaction with H2O, water molecule, catalyst in the presence of corn sulfuric acid. So already we know water molecule is split as H plus OH minus. The product formed is CH3, CH, CH3, OH. So the compound name is propene or propylene. It follows Markovnikov rule. So Markovnikov's addition. Remember? So the actual mechanism, carbon is polarized, the gain of electron charge minus, carbon loss its electron plus. So Markovnikov rule, negative part is added to the carbon that carries least hydrogen. So negative part is added to the carbon that carries least hydrogen. So in this carbon contains only one hydrogen, remaining 2 or 3 are there. So the OH is added over this carbon to form propyl alcohol. It is an isopropyl alcohol. Branch is there, so common name is isopropyl alcohol, IPAC propanol. So third one, Grignard reaction. Grignard reaction or Grignard, using Grignard reagent. This one already we studied in 11th standard. If it is formaldehyde, it will give primary alcohol. If it is acetaldehyde, it gives secondary alcohol. If it is acetone, it gives tertiary alcohol. So I will teach one topic, remaining topic you will try it in home. So Grignard reagent formula RMgX or CS3 Mg or in all the topics halide with minus. In case of Grignard, MgBr plus, CS3 group is minus. So once again I am telling, I will explain for one topic, remaining two concepts, secondary and tertiary, you will try it in home. So Grignard reagent CS3 MgBr, formaldehyde structure representations HC double bond OH. First step, so MgBr plus is polarization minus plus, this minus added over plus form CS3 CH, as it is there HCH, on top you have CS. This MgBr added over oxygen, so OMgBr. Next step on hydrolysis. So water molecule split as H plus, so OH minus. We know. So among this, which one is electronegative? Because MgBr already is positive, so O minus. So the H plus added over O minus to form HCH CS3OH. The compound name is ethanol or ethyl alcohol. Similarly, you try for secondary and tertiary. For secondary, the structure representation of acetaldehyde is CS3C double bond OH. In case of acetone, CS3C double bond O CS3. So Grignard reagent react with. So you do it in any class of note and take a photo and send to the classroom. So this one, same, plus, minus, on polarization, minus, plus. Similarly, you try for secondary and tertiary. If acetaldehyde gives secondary alcohol, isopropyl alcohol. If it is acetone, it gives tertiary alcohol. Fourth one is hydroboration reaction. In hydroboration, propylene on reaction with the diborane, so already studied in B block, it form trialkyl borane, CS3, CH2, CS2, thrice, form tri. In this case, alkyl group is propyl group, so tripropyl borane. These on reaction with peroxide. H2O2. So H2O2 we can write it as HO and HO. you take 3 hydrogen peroxide, so it contains 3 plus 3, 6 OH group. So 3 OH is added over one alkyl group. This 3 OH added over to boron group. The product formed is CH3, CH2, CH2 not balanced. So in this case number of boron is 2. So you put 2. 2 3s are 6, so 6. So product formed is eliminated product is BOS thrice. So product form name is propyl alcohol or propanol. IUPAC name 1, 2, 3 propane. E replaced functional group present in first carbon, so propane 1 all. So it is an important topic. They will ask in board exam any direct 3 mark question. Equation alone you write. So fifth one is reduction. So only aldehyde reduced by using lithium aluminum hydride. So normally we use only lithium aluminum hydride because this alone will reduce carbon-carbon double bonds. So I will give one compound. Suppose you take acetone on reduction using LiAlH4. So normally reduction 4 molecules of hydrogen is used. You polarize 2 minus plus. These 2 hydrogen is split as H plus and H minus. So H plus added over OH, H minus added over plus. So product formed as CH3, CH, CH3, OH. It is an isopropyl alcohol. Common name or IUPAC, any one name you write, it is correct. Isopropyl alcohol. Similarly, you try for acid, benzoic acid, structure presentation C double bond O, OH. On using LiAlH4, same 2 molecules of hydrogen. So on polarization minus plus. So H2 is split as H plus H minus. This plus added over minus. This minus added over plus. So compound formed as C6H5 CH OH OH C6H5 CHOH CH2OH CH2OH. So these are product formed in case of benzoic acid. If 2 functional group is present in the compound, then the product is, you take any or CO, CH2, CH2, COOH. Here see one functional group is CO, another functional group OH. If 2 functional group is present, then the reagent is sodium boride because it is a less reactive, less vigorous. So it reduces more reactive group. So in this case, this carbonyl ion undergo reduction. The product formed is RCH, OH, CH2, CH2, COOH. So naming 1, 2, 3, 4. So fourth group contain alkyl group. So 4 alkyl. Fourth group contain hydroxyl group. So 4 hydroxy. And remaining is 3 carbon. Remaining 4, 1, 2, 3, 4 carbon. So butyl. Functional group is COOH, so end with oic acid, so butanoic acid. So last preparation. Last preparation is preparation of glycol. So glycol formula CH2OH, CH2OH. It is an important topic. It is prepared by using ethylene. ethylene on oxidation in the presence of water molecule. The reagent used is cold alkaline KMnO4. So in this case, you see number of oxygen is 2, number of hydrogen is 2. So 2 OH means we can split it as OH and OH. So one OH minus another OH plus. So you polarize, plus added over minus, minus added over plus. So product formed as CH2, CH2, OH, OH. Important topic, they will ask 2 more questions. This reagent is called base reagent. Already we studied in 11th standard. Base reagent. So ethylene with cold alkaline KMnO4, it forms glycol. Ethylene glycol. Ethylene glycol or glycol. So last one is glycerol. This is also an important topic. So glycerol is prepared from CH2O, C double bond O, CH2, CH2, 14 CH3, CH2O, double bond O, CH2, 14 CH3, CH2O, C double bond O, CH2, 14 CH3, react with the NaOH. This compound name is glyceryl palmitate. Glyceryl palmitate on reaction with the NaOH. Number of glyceryl carbon is 3, so take 3 NaOH. You can split this compound. Minus electronegative, this is plus. So already you know Na plus OH minus. This minus is added over first carbon. We have 3 carbons, so 3 OH minus we have. This 3 OH is added to one carbon. The product formed is CH2OH, CHOH, CH2OH. The eliminated Na is added over this oxygen. So NaO, C double bond O, CH2, 14 CS3. So number of molecules 3. The product formed as, this one is called as glycerol. This eliminated product is sodium palmitate. Sodium palmitate, this one used in the soap. This one is precipitate, so used in soap. The overall process is saponification. So among this preparation is over, next we will see properties. Among this preparation, saponification important, glycol preparation important, next this Markovnikov of addition and the hydroboration topic is very very important. This one already we studied in 11th standard. These 2 topics you try and post it in Google Classroom. Thank you. Next we will see properties of alcohol.